Hi there. In this video, I'm doing another work problem, and this is a work problem that once again involves pumping water out of some type of a tank or a trough or some type of a vessel. So let's get started. A trough of water is 8 feet long and 1 foot high. The vertical cross section to an end is shaped like the graph of y equals x squared over the interval from -1 to 1. The trough is full of water. Find the work in pumping the water over the top. And the weight of water is 62 pounds per cubic feet. So the first thing to notice is that this is in US units, standard units. This is not in the metric system. So we will not be using the density of water being 9.8 and the mass of water being 1,000 kilograms per cubic meter. All we have to use is the weight. But before we get to the actual formula, let's draw ourselves a picture. So we have a parabola once again, and my parabola is going to look something like this. And the equation of the parabola is y equals x squared. And we are going from x equals -1 to x equals 1. So right here, we're going to have x equals -1 and x equals 1. I am going to put the parabola once again at the origin. Let me put my axes in another color. So this is the vertical y-axis, and this of course is going to be the x-axis. And so whenever I am doing a type of problem and I'm using some type of a function, I like to try whenever possible to center the function at the origin. And so in this case, I am going to say that the height of this trough, so this is going to be the height of the trough, right here. And so this distance from here to here is the height of the trough. And I'm going to let the height of the trough be y. This will be y equals 0. And so we need to figure out what is the height of the trough. Well, we're going from x equals -1 and 1, so what is the y value? So we have y is equal to 1 squared, which is 1, and -1 squared is 1. So this is y equals 1, okay? Because these points right here are the points 1, 1, and this point here is -1, 1. The important thing is the y value is also 1. So we're going from y equals 0 to y equals 1. The trough is 8 feet long, and it says that it's 1 foot high. I guess it did say that, so we didn't have to figure that out, but now we know how to figure it out. So what we need to do is we have our work function. Work is going to be equal to the weight of water, which is given as 62 in this problem, rather than 62.4, times the integral from A to B of volume. So remember, the basic work formula for pumping is volume times distance. We need to figure out the volume of the water being pumped and the distance that it is being pumped. And so once again, instead of using density, rho, and g, we're just using the 62. We don't have to use those. Okay, so let's figure out the volume here. That's always the most difficult part. So the volume, let's take a little slab. Let's take a slab of right across here. And so we want to figure out the volume of this little slab. All right, well, to figure out the volume of that slab has length, it has width, and it has height. Well, we're going to call the width of this, because it's along the y-axis, let's call the height delta y. And because I'm using y value, you can think of it like doing little rectangles. Well, the rectangles are, are along the y-axis. The length of the slab, that's going to be the length of the water trough, is 8 feet. That is 8 feet. And so then we have W. We don't know what W is. This here is going to be W. So how do we figure out what W is? Well, W is 2 times, let me just call this little part in here, let's just call that R. W is equal to 2 times R. And so how do we figure out what R is? Well, R is the distance from the graph to the y-axis. Well, that's either an x value, or because we're doing delta y here, let's solve our equation for x. So if y is equal to x squared, x is equal to the square root of y. So this distance r is going to be equal to the square root of y. 2 times the square root of y. Okay? Because this is the graph of the function right here. The point on here is going to be the function value. The height of this from the y-axis to the curve is the function value. Well, the function value is, in terms of y, the square root of y. Okay, so the width is 2 radical y, so we plug that in here. 8 times 2 radical y delta y. There is my volume. Now, the next thing we need to do is figure out the distance. So the distance is going to be, how far does this slab have to be pumped from here up to here? We want to find that distance. Well, if we're starting with y equals 0 at the bottom, then the distance from here to here is a y value. If this whole thing is 1, then this distance here is 1 minus y. And you see this is common. We've done this in other problems. There's quite a few problems where you're going to use this basic technique. So the distance is 1 minus y. Well, the last thing to do is to figure out the bounds of integration. The bounds of integration, in this case, is not too difficult. The bounds are along the y-axis, greater than equal to 1, less than or equal to 1, greater than or equal to 0, because we're pumping from y equals 0 up to y equals 1. Okay, so let's put it all together. The work being done is equal to 62 times the integral from 0 to 1 of my volume, which is 16 square root of y. And now the delta y is going to become dy, and I'll put that out here. That comes out there. And then the distance 1 minus y. 1 minus y. And so we can simplify that a little bit by, first of all, we have to, let's bring out the 62. 62 times 16 times the integral from 0 to 1. Now, y to the square root of y is y to the 1/2 times 1 minus y dy. All right, well, let's figure out what 62 times 16 is. 62 times 16, it appears, is 992. So W is 992 times the integral from 0 to 1. Multiplying this through, we have y to the 1/2. And multiplying this, we have minus y to the 3/2 dy. All right, that is my simplified radical, ready to take the antiderivative and then evaluate it at 1 and 0. So in this video, I am just going to get you to the point where we're setting up the integral, because I believe that's really the hard part as far as actually integrating this. First of all, I would enter this into Desmos, get a decimal answer for it. Then I would actually go through, find the antiderivative. So it's going to be 2/3 y to the 3/2 minus 2/5 y to the 5/2, and evaluate that at 1 and multiply it by 992. And you're done. And make sure that agrees with the answer you have in Desmos. All right, so for those of you that asked for a video on this, I hope this was helpful. If it's not, let me know. I need to know these things. If it was helpful, great. I will see you in class.